Good morning. Today I am going to tell you one specific model based on Coulomb's law. So, here between two charges Q1 and Q2 separated by a distance r, electrostatic force of attraction or repulsion is given by F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. That is the first expression. If the space between the charges is filled with a dielectric, or if the two charges are in a dielectric medium of dielectric constant K, then the force between them will be equal to 1 by K times 4 pi epsilon naught Q1 Q2 by r square. See here, the two charges are completely immersed in a medium of dielectric constant K separated by the same distance, then 1 by K times 4 pi epsilon naught Q1 Q2 by r square. Now, we are going to find out the equivalent thickness of dielectric. So, we will see what does it mean. See here, in air between two charges force is 1 by 4 pi epsilon naught Q1 Q2 by r square. Now, in a medium of dielectric constant, the force between them is 1 by K times 4 pi epsilon naught Q1 Q2 by, suppose if the distance is r2, say, if the distance is r2, or if the thickness of the dielectric medium used is T, so T square, right? Then the force between them, do you understand this concept? The two charges now are separated by a distance T. Then the force between them is Q1 Q2 1 by K times 4 pi epsilon naught Q1 Q2 by T square. If the two forces are equal, if F dash is equal to F, what does it imply? 1 by 4 pi epsilon naught Q1 Q2 by r square, where r is the distance between them when they are placed in air or free space. That is equal to 1 by K times 4 pi epsilon naught Q1 Q2 by T square, where T is the distance between them when they are placed in a medium of dielectric constant K. Then what do we get here? 1 by 4 pi epsilon naught Q1 Q2 gets cancelled. K into T square is equal to r square, right? Or from this expression, T square is equal to r square by K or r by root K, or r is equal to root K times T. R is equal to root K times T. Is it okay? Just from this, if you take square root on both sides, R is equal to root K times T. This is very important. A dielectric slab of thickness T, constant K, behaves like an airspace of thickness root K times T. Okay? So, I am repeating the statement. That is the proof, but ultimately you have to have that concept in your mind and you have to have the relation. So, here 1 by 4 pi epsilon naught Q1 Q2 by r square is 1 by K times 4 pi epsilon naught Q1 Q2 by T square. That is what is given. So, r square is equal to K T square. So, r is equal to root K T, meaning the effective air length is equal to root K times the dielectric constant thickness. Okay? So, based on that concept, remember this. Look here. Force between two charges Q1 Q2 separated by a distance r. Force between two charges separated by a distance r is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. Now, This is the first equation. This is the first situation. So, this is the equation corresponding to that. And the second thing is, between the two charges Q1 and Q2 separated by a distance R, a dielectric slab of thickness T, constant K is placed. What is the new force between them? So, from Coulomb's law, F is equal to 1 by 4 pi epsilon naught, meaning you are considering the entire thing as air. Then you see what happens. Q1 Q2 by, what is the air thickness left? R minus T. Air thickness left is R minus T. And now this dielectric slab of thickness T is equivalent to air thickness of root K into T whole square. That is the expression. Do you understand? See here, in the previous thing, dielectric slab of thickness T constant K is equivalent to air thickness root K into T. Now, in this case, it is placed like this. So, air thickness becomes R minus T. Effective dielectric thickness, that is the equivalent length of air column, becomes root K into T. So, the new force of attraction or repulsion becomes F dash is equal to 1 by 4 pi epsilon naught Q1 Q2 by R minus T plus root KT whole square. Very important relation. So, I will give you one problem based on that concept. You see here, force between two charges separated by some distance in air is F. F is the force of repulsion between two charges separated by some distance in air. Now, a dielectric slab of constant 5, thickness T equal to R by 2 is placed between them. So, I am repeating the problem. Two charges Q1, Q2 are separated by a distance R. Force between them is F. Okay, now what is the new force when a dielectric of constant K 5 and thickness R by 2 is placed in between them? So, let us do the problem carefully. F is given as 1 by 4 pi epsilon naught Q1 Q2 by R square. F dash is, let us take that K as not 5, 4. You understand why I am taking 4. Okay, so 1 by 4 pi epsilon naught Q1 Q2 by, instead of R minus T plus root K into T whole square. Now, look here, this becomes 1 by 4 pi epsilon naught Q1 Q2 R minus, thickness is R by 2 plus root K is root 4 into T is R by 2 whole square. So, what happens is 1 by 4 pi epsilon naught Q1 Q2 by R minus R by 2, that is R by 2. R minus R by 2 is R by 2. This and this gets cancelled, plus R whole square. So, I am rewriting this here. F dash is equal to 1 by 4 pi epsilon naught Q1 Q2 by R plus R by 2 is 3R by 2 whole square. So, this is 1 by 4 pi epsilon naught Q1 Q2 by R square 9 by 4. So, Q1 Q2 by R square is F. So, F dash is equal to 4 by 9 times F. That is the answer, right? So, here this is the important formula you have to memorize. Actually, if you have the concept in your mind, you need not memorize that strong. See, 1 by 4 pi epsilon naught q1 q2 by r minus t, equivalent thickness is root kt whole square. R minus r by 2, root k is 4, r by 2, so gets cancelled. R minus r by 2 is r by 2 plus r, 3r by 2 whole square means that is the answer. Okay. The final force becomes 4 by 9 times F. So, another model I am telling you on Coulomb's law. Look here, for that model you should have one thing in mind, potential on the surface of a charged sphere. Potential on the surface of a charged sphere is given by 1 by 4 pi epsilon naught q by r. See here, this is a conducting sphere having charge q, radius r. Then on the surface or potential of that charged sphere is 1 by 4 pi epsilon naught r. That we know. And we are just recalling the fundamental principle involved in the conduction method of electrification. When two charged bodies are placed in contact with each other, redistribution of charge takes place. Redistribution of charge takes place till their potentials are equal. When two charged bodies are placed in contact with each other, redistribution of charge takes place till their potentials are equal. Okay? Now, keep those 2 points very clear. Now, two spheres of charges q1 and q2, radii r1 and r2 are placed in contact with each other. First step is those two charged spheres are placed in contact with both of them. They are charged spheres. Whatever is the charge, positive, negative, doesn't matter. So, they are placed in contact with each other and then isolated, separated from one another's influence. So, this is q1, this is q2. Now, when they are separated, let the charges be q1 dash and q2 dash. q2 dash. So, here the question is like this. Two charged spheres of charges q1, q2, radii r1, r2 are placed in contact and then separated, isolated or separated. You need to find out the final charges q1 dash and q2 dash. See here, when they are placed in contact with each other, the charge redistribution takes place till their potentials are equal. So, look here, the total charge available is q1 plus q2. That gets divided among the two spheres till the potentials are equal. What is the expression for potential? V is equal to 1 by 4 pi epsilon naught q by r. So, this is same for both. As V is same for both, charge is directly proportional to R, only then their potentials will be equal. So, coming back to the basic concept, when two charged spheres are placed in contact with each other, redistribution of charge takes place till their potentials are equal. From the expression for potential, if potentials are same, charge distribution is directly proportional to the radius, right? Based on that concept, the total charge divides among the two in the ratio of their radii. This is the most important thing. So, when two charged spheres are placed in contact with each other and separated, then the charge divides in the ratio of their radii. So, R1 is to R2. Then Q1 dash is equal to Q1 plus Q2 into R1 parts out of R1 plus R2. This is the charge on the first sphere after redistribution. Charge on the second sphere becomes Q1 plus Q2 into R2 by R1 plus R2. This is the most important thing ultimately we have to memorize, right? So, look here, when two charged spheres of charges Q1, Q2, radii R1, R2 are placed in contact with each other and separated, then redistribution of charge takes place till they acquire a common potential. Then the charge divides in the ratio of their radii. So, try to understand the concept and arrive at the final formula. Total charge is Q1 plus Q2, it divides in the ratio R1 is to R2. So, Q1 dash is equal to Q1 plus Q2 into R1 by R1 plus R2. Similarly, Q2 dash is equal to Q1 plus Q2 into R2 by R1 plus R2. Now, a special case is, suppose if radii are equal, R1 is equal to R2, then Q1 dash is equal to Q1 plus Q2 by 2 and Q2 dash is equal to Q1 plus Q2 by 2. Meaning, if there are two identical spheres, then charge divides them equally, Q1 plus Q2 by 2 on both the spheres. Okay, I will stop here. Thank you and bye-bye.